How's it going, everyone? Welcome back. And so today, as you can see by the title, we're going to be talking about the OSI model. And OSI models are something that's been discussed for many years on the networking side. I wanted to do something a little bit different with this video. You can probably find the general overview of the OSI model, explaining each layer in a lot of detail when it comes to general networking. In this case, I wanted to tie this back to OT, or operational technology, because ultimately that's what we're talking about in this specific section. And so I'm going to be using some examples from the real life, from manufacturing, industrial automation, to tie in how you should be thinking about these layers. Now, of course, we're going to get into a lot more detail with some of the other lectures, but in this case, I'm going to provide you an overview. So let's start from the bottom, which is going to be your physical layer, and I'm going to write it here at the very top, but we will progress basically from the lowest layer to the highest. And so physical, one of the most important layers in our industry, because a lot of times you will be dealing with networking cables, you will be dealing with ports, you're going to be dealing with ruggedized hardware. And so in a nutshell, right, when we talk about Ethernet-based protocols, you're going to be dealing with a lot of these RJ45 either pre-molded or cables that you can create by crimping, because you're pulling those network cases through conduit and through different basically enclosures, unlike the traditional network setting where everything is nice and neat and the physical layer doesn't always get troubleshot. On the plant side, this is very different because, as I've said, number one, the cables are rarely going to be pre-molded. The cables are usually ran to high voltage lines, which creates noise and traffic, obviously, in the packets, but the physical layer is very important to understand for someone working on the OT side. Next, we have the data link layer. So data link, and this often refers to your MAC addresses. So what I want you to also retain is the layer numbers, because in certain instances when you talk to either people at the plant, but more often people that you will call upon on the IT side, they will refer to them as a layer 1 problem, a layer 2 problem, a layer 3, so on and so forth. So you should also be familiar in a general sense when we're talking about the number where the problem actually is. So data link refers to the MAC addresses. And so if I refer back to the ISP device that I had shown you in one of the videos, we will talk about MAC addresses in a lot more detail, but basically you will have a little label on almost every device that's going to specify the MAC address of that specific piece of hardware. And the same goes, for example, this is an opto controller from Arduino. You're also going to have an Ethernet port, and there's going to be a MAC address specified, usually on the label on the side or on the front of that specific item. And so anything that has an Ethernet-based connection is going to have basically a MAC address. Like I said, we're going to talk into a bit more detail in a different video. Here's an IPC from Phoenix Contact. Similarly, it has 2 Ethernet ports, and those are going to have either, in this case, it is the same basically IP address, so it's going to have a MAC address. And the same goes for PLCs, for VFDs, for servo drives, for your remote I/O, for your safety I/O, and other devices on your network. Next, we have the network layer, right? So this is layer 3, and this is becoming also important because, as you will see in some of the lectures that will follow, and so this becomes important because it becomes a question of a switch problem or configuration, or a router configuration, or even a layer 3 switch. So it's easy to get confused, but as we go through some of these lectures, we will obviously unravel that. But layer 3 is your IP addresses. So when you configure your devices, it is important to understand that the MAC address is going to be static, meaning that it will be assigned by the manufacturer for that specific device. An IP address is assigned by the user, or usually, I guess, if we can take 2 steps forward, it can be assigned by the device that you're connected to. So going back to the home network that we've discussed, usually the router is going to assign an IP address, which is a unique identifier to each device on the network, and that's how they're going to know what the address of each one is. But the MAC addresses are going to be static out of the box, while the IP addresses can change. So network layer 3, extremely important for the OT side. We will talk about routing tables, we will talk about how to assign IP addresses to different devices, and in a very general sense, it is possible to assign a different IP address to nearly all devices that will have Ethernet connectivity. Transport. So transport is, I would say, a less important layer to understand in OT, but still comes into play when you're talking about data exchanges. So in most instances, this is going to be handled by your application or by the settings of your device. So you're not going to have to necessarily choose as often which protocols that you're going to be using, but in this case, it's going to be TCP and UDP. And we're not going to spend a whole lot of time discussing the protocols, but some of them are going to be basically deterministic, and the other ones are going to be without any checks, right? So you can have communication between two devices where you're going to have a handshake and you need to make sure that the packets go there without loss. And then you're going to have protocols that will just basically send out information and hope for the best, so to speak. And there's going to be different applications of each one, but in a nutshell, that's what they're going to be used for. Next, we have the session layer, the presentation layer, and the application layer. And so I usually bundle the three of them, and this is going to be handled by the software that you basically are running on your specific device. This is going to be handling your packets, your headers, your tails. I don't believe that there's a whole lot of value for us to talk about this, because in most cases you have an abstraction that is going to handle all of this, except in very specific scenarios. So if you're going to go all the way down to, for example, use something like Wireshark and try to understand the packets and try to understand not only where they're coming from, but what they actually contain, if you're going to decipher some of that information, then those layers become important. But ultimately, it is not something you will either have to handle or configure on your own. So I would honestly not spend a whole lot of time in this area. I would learn as much as you can about these four layers at the top and have working knowledge when you're in OT, solving some of the problems, when you're communicating with tech support, so on and so forth. If you have any questions about OSI layers, like I said, there's tons of different videos without the manufacturing context, but if you have something specific on manufacturing, don't hesitate to leave us a comment and we'll answer as soon as possible.